Hi there, this is a little video about solving nonlinear inequalities. I'm going to show you a different strategy though. This is called solving nonlinear inequalities by graphing. Okay, so you have already seen a couple of videos by now about solving nonlinear inequalities, and the method that they showed you on those videos is a very good method. For example, something like x squared minus 4x minus 12 greater than 0. What you were shown there was to factor that polynomial into x minus 6, in this case x minus 6 times x plus 2 greater than 0. And think about it this way, it's greater than 0. Two numbers multiplied together give you a product greater than 0 when it is a negative times a negative, that's greater than 0, or a positive times a positive, that's also greater than 0. So then you were instructed to take these two factors and find the critical values that make this expression equal 0 and put them on a number line. So that would be negative 2 and positive 6. And then you tested values in here, in these different intervals between these two numbers. You got two numbers, that gives you 3 intervals. So you test a value less than negative 2, and you find that that gives you a number less than negative 2 in the first factor, x minus 6, would be a negative number, and then in this other factor, x plus 2, would be also a negative. So that's positive. So that's good. That region right there then represents one of our solution areas. Then you test in the middle version there, negative 2 to 6 in this interval here. And let's say you try to 0, you'd have a negative 6 times a positive 2. That's a negative times a positive. Well, that's negative, and we don't want those because we're trying to find solutions that say greater than 0. Then you test this area over here, greater than 6, and you find that gives you a positive times a positive, and that's positive, so that's good. And your solution ends up being, for this inequality here, the interval from negative infinity up to negative 2, union the interval from positive 6 to infinity. And that's your solution for this nonlinear inequality. Okay, so we got that solution there by following this method here of finding the factoring the polynomial first, finding the little critical points, testing values on a number line, which finally give us the correct intervals there, our solution. Now that's great. If you have not taken a good look at those videos that explain that method in more detail, please stop what you're doing right now and go back and look at those videos. You'll get a lot more out of it than me just ripping through the process like I've just done. This video has a slightly different purpose. I want to show you how to do the same kind of a problem, but without the testing between values on a number line. I want to use graphing as a way of solving these nonlinear inequalities. And so this video that you are looking at now assumes that you are pretty good at graphing functions. So that's what I'm going to go with here, and so I'll show you how this works. Let's start with that same polynomial expression there, the same nonlinear inequality. And instead of saying x squared minus 4x minus 12 is greater than 0, just for a second here, what I want us to do is to consider what if that was not less than, or greater than 0, but it was equals y. In other words, it's a polynomial function that you are graphing. Y equals x squared minus 4x minus 12. Well, one way that you might get at least a basic sketch of that polynomial is to do the same thing that you did before. Factor it to find the 0 points, or those critical numbers. And of course, it's the same factoring, x minus 6 and x plus 2. Okay, and if you took that expression right now that we have and applied it to a graph, an xy axis, what you hopefully would do would be something like this. This gives me two numbers. One of them is negative 2, and the other one is positive 6. And my parabola looks something like this. All right, it goes through those points. What I'm hoping that you remember from your experience graphing polynomials is that when you factor a polynomial like this, you are actually finding the zeros, or sometimes we call them the roots of this function, the x-intercepts, in fact, of this function. So instead of a number line, it's the x-axis. And instead of just testing values, you've drawn the graph. Now, look at the graph. In between -2 and +6, these are where the y values are less than 0, right? The x values between -2 and +6 in this function give y values that are less than 0. Whereas greater than 6, that's where y values are greater than 0. It's above the x-axis. Over here, less than -2, it's y values that are greater than 0. The graph is above the x-axis. That means the y coordinates on the graph are all greater than 0. So, in a sense, the graph of this function right here illustrates where it is greater than or equal to 0. So now, if I take this and I say x squared minus 4x minus 12, what did we say? We said greater than 0. Well, the graph is showing us where it is greater than 0. It's greater than 0, less than -2. All of this area up here, that's where the y values are greater than 0. So that's one of our intervals, from -infinity up to -2. And the other interval is over here, where the y values, again, are greater than 0, and that's where x is greater than 6. So the union of those two intervals, -2 to -infinity to -2, and 6 to +infinity, is where this function is greater than 0. So that's the idea, okay? Oh, here we go. So that's the idea, excuse me, of this method. So let's try a couple of other examples, and I think you'll get the hang of it as we go through these. So let's try this one right here, x squared plus x minus 2 less than 0. And this one factors to x plus 2 and x minus 1, okay? So if we think about that in terms of the x-intercepts of that function, just make a quick sketch right here. Our x-intercepts are going to be at -2 and +1. And the parabola does something like this. I don't know exactly how far down it goes. I don't even care how far down it goes down here. It doesn't matter. All I know, or all I care about, is that it's below the x-axis, in between these two numbers, and it's above the x-axis on the outsides of them. This inequality, less than 0, this tells me that this is the region that I'm looking for. So the solution for this one is -2 to +1, and I'm done. There's no testing of numbers that I have to do. That's it. The graph tells me the answer. So let's try a different one here. We've got this one here, -x squared minus 3x plus 4 is greater than or equal to 0. Okay, well, the -x squared is throwing me off a little bit, so I think what I'm going to do is just factor out the -1. So I got -x squared plus 3x minus 4 is greater than or equal to 0. Okay, just factoring out the -1. And now, let's see, I think I can factor what's inside here. X plus 4 times x minus 1 is greater than or equal to 0. Okay, so I've done that. Now, if I try to make a sketch of this, I'm going to look at my x and y axis here. I'm going to see that I've got to have a root at +1 and at -4. But this negative sign out there means that my parabola is upside down. So it looks something kind of like that. So there's a 1, there's a -4. And now I look at my inequality symbol, greater than or equal to 0. That means above the x-axis. Up here, there's my solution. It's pretty easy. It goes from -4 to +1. With brackets because it's greater than or equal to. And that's the method, guys. It's actually a pretty simple way to do it as long as you can graph these functions. So that's about all I wanted to say here. This video here kind of describes that method. All you have to do is be able to graph a function, and the graph of the function tells you where it is greater than or less than 0. In its relationship to the x-axis. Okay? So I'll do another little video about rational inequalities, that is nonlinear inequalities that involve rational expressions rather than polynomial expressions like this. But until then, as Forrest Gump likes to say, that's about all I have to say about that. Enjoy.